Hi everyone, welcome back to Dragonfly Engineering. So this week we are going to assemble this mold, which I showed the CNC machining process the last few episodes. And this week is the actual assembly of the mold. So we're going to put all the ejector pins in, cut the ejector pins, and just assemble the whole thing. And then run it on the dual shot molding machine, which is this guy right there, which we just loaded or moved into this new area of the shop. So I hope you enjoy this episode. Also, I was trying out a new microphone and the audio was all messed up. So for a lot of the assembly, I just did a voiceover. So sorry about that. I'll have to figure out my microphone situation for the next episode. Okay, enjoy this build and I will see you guys next week. All right, so this is the machining operation finished. And this is me testing the ejector pins through the reamed holes. This is some footage from the last episode where there's pretty much a montage of just showing the machining operations for these two mold halves. There I'm testing the fit of the ejector pin with the little pop sound. And this is my wife April, her hand spraying some WD-40 on machining all of the ejector pins. So we're using a manual mill here, and basically you just keep spraying coolant on the ejector pin that's set in that vise with a hard stop. You have to make the ejector pins the exact height of the B side mold stack, which is the side that ejects. Here's an up close view. And you can actually machine these ejector pins if they are of reasonable hardness. I think these are Rockwell C40 ejector pins. And you got to keep them cool and use the top of the flutes for your end mill. And then moving on to the actual mold body itself, we pressed in these copper cooling lines into the machined profile. This is on the back of the A side, and then that's the A side plate that basically bolts on, which contains the cooling line and heat sinks it, as well as creates the ledge for the clamps to clamp this half of the mold onto the platen of the molding machine. And here I'm using basically Home Depot purchased bolts, or hex head bolts, mostly because the steel that I got from the local supply company was only 5/8 of an inch thick. So I couldn't use the usual socket cap head screws. So I added an extra bolt in the middle there. And then here I am cleaning out some of the blue paint that was used as a mask for the bottoms of these features. The rest of this cavity was actually bead blasted. And here we are drilling and machining the pedestals. These pedestals are used to support the ejector side of the mold, and you'll see how these are assembled into the mold later in the episode. But I'm just pretty much manually turning these. So there I drilled the pilot hole, and then I'm going to set up with a 1/4-20 tap using a little spring-loaded plunger. There I'm pulling the drill bit out. There's the spring-loaded plunger, which basically keeps the tap aligned with the hole that you just drilled. And then I basically just hand tap using the tailstock of the lathe to keep your tap nice and lined up. This really helps preventing breaking your tap. I don't know, some of the machinists out there probably have bad memories of breaking off a tap and apart. But if you leave it aligned in your mill or in your lathe, in this case, then you have a better threaded hole and less chance of busting your tap. And again, that pedestal will hold the back, or basically support the B side of the mold block from deforming from the about 10 to 15,000 psi pounds per square inch of pressure that the molten plastic applies to the mold itself. Again, I'll show how those are assembled later. But here I'm just showing a quick trick to basically add a threaded stud to these pedestals. And I'm just basically force driving these 1/4-20 bolts into the threaded hole we just made and driving them in as hard as I can. And then you basically just cut off the head of the bolt like I'm doing here. And now you've got pretty much a permanent threaded stud into your pedestal. And then you clean that up on a grinder, which is what's going on here. And as soon as I turn it on, and you basically, of course my shoulder's in the way, but you you spin and you clean up the leading edge of your thread, and then grind your stud or your threaded stud square to be ready to be screwed into the base of the B side of the mold. And yeah, just kind of fuss with it a little bit, and it works out. And that's basically just a cheap sander from the hardware store. All right, now I'm prepping the back plate of the mold, and you can see how the pedestal screws in. And that pedestal is the same height as the riser blocks, which are those blocks to the left. There I'm just kind of tightening them in with the handy old vice grip. And basically I'm jamming these threads to, avoid the need maybe for Loctite. All right, and then the B side of the mold also has a cooling line in it, and this is recycled copper that April formed and used that pattern to basically snake the copper around and tap it in using a rubber mallet. And then you just sandwich the copper into that backer plate. You can see that backer plate basically just supports the thinner plate that has the B side core profile of our mold itself. So if we just molded directly onto that 1-inch thick block, then it would have deformed too much. So we add an extra 2-inch block behind it, which is also convenient to sandwich our cooling line. Because this is a steel mold, and steel conducts about 1/10 as good as aluminum molds. A lot of times I mold with aluminum because you don't have to worry so much about cooling. But in this case, we have this cooling line and this backer block, the 2-inch block. You can see all the ejector pin holes are basically just through holes, and the precision ejector pin holes are in the actual core plate of the mold itself, which I showed being machined in a previous episode as well. All right, so now we are starting to set up and assemble our ejector plate. And the ejector plate basically holds all of the ejector pins that goes through all of those precision reamed holes. And the plate is guided by those guide pins there. And the guide pins do a few things. One thing is that they actually just keep the ejector plate action or motion square. They also push the ejector plate back when if there's some issue with the molding machine. You don't want your ejector pins to gouge the A side cavity, which is the cavity to the right in this picture. So those pins will actually, when the mold closes, it will force the ejector plate back to its home position, which is opposite of this position right now. But you do, when you're assembling your mold, you do need to push your ejector plate all the way forward so that it's easier to string all of your ejector pins. These are the ones that April had machined into all of the precision reamed ejector pin holes. So here we just go through the process. You got to clean them, slightly lube the pin, and make sure it's the correct height. And here basically I string it through. And these ejector pins have an extremely tight tolerance on the actual leading edge of the core. So it's so tight that you actually have to tap them in. It's approximately 1/10,000th clearance, anywhere from 1 to 3 10,000ths, or 2 to 10 microns clearance for the metric folks. And so this is just the process. Now, the plate that receives all of these ejector pins has pockets in it that you can see in the back there. And the pins themselves have a foot that's like basically welded on, and you buy an ejector pin like that, and then you cut it to length. So all of the little pockets you see on the back of that ejector plate receive the foot of the ejector pin, which is basically just a larger diameter flange. And that way your pins are held in place. So when you do have all of these parallel pins and sliding action like this, the plate does tend to bind up a lot, especially in a steel mold that has extremely precise alignments.
The plate loosens up a little bit.
So you usually always need like a pair of screwdrivers or something to get the ejector plate to start moving away from the kind of the jammed up zero position of the back of your mold. So here I'm now adding all the 1/8 inch and 3/32 diameter ejector pins, and usually these smaller diameter ejector pins have like a step in it, like an 1/8 inch base, and then like the final diameter is smaller, and they do that so that the ejector pin doesn't buckle from just it being so spindly. And there you can see how I'm showing how all of these ejector pins can't quite go all the way to the front because they do have this shoulder on them. So I can only get the ejector, the shouldered ejector pins to go that far. And then, but I go ahead and stick all the rest of them in. And then there's one last ejector pin in the middle, which is 3/16 of an inch. And that is the one that ejects the sprue out. And you can see that empty little pocket there in the middle, which I will stick the final pin in at the end. There you see that the final pocket there. You typically do have a couple of pins that give you problems, so you pretty much just have to deal with it. And a lot of times that involves either drilling out slightly bigger holes for the back plate, etc., etc. Now these are the die springs, and these springs are used to push the plate back when the molding machine is done ejecting the part. You can have a molding machine pull a plate back, or you can just have it push a plate forward and rely on the springs in the mold to push the plate back. There's good and bad aspects to both of those, but in this case, or in general, this mold was such a kind of a safe situation for ejector pins that I went ahead and opted for the spring return versus the pole return from actually tying the ejector plate into the piston of the molding machine. In this case, it just pushes forward and the springs will push the plate back. Now, like I mentioned earlier, those return pins, if there was some problem, like the plate bound up and the springs couldn't return the ejector plate, then the tips of those 4 pins that guide the plate would actually push the plate back as the mold closed to protect your mold surface. And here's me drilling out a couple of holes in the back plate, because again, everything is kind of ultra precise, but sometimes when you add up all these pin clearances, you can have a few that are just a little on the edge of too precise, and then you have binding problems. So I'm just opening up some of those holes just with a hand drill, and that's fine as long as you don't like drill all the way through the pocket so that the foot of the ejector pin like pulls through. Then you can do this kind of quasi-ghetto action to just get all your pins to be happy, because ultimately you want the plate to move forward and back. So here I'm lubing up that plate or that pin a little extra to kind of debug the situation. I don't really like to lube up these pins too much, especially for like food product molding, because you don't want any kind of grease and stuff. Or you use cooking spray instead of like motor oil or something. All right, so now what I'm doing is I'm pulling these, or I'm kind of checking the feel of everything. And as you can see, it's when you have like 30 ejector pins and 4 return pins and everything, you still have to dial in a few aspects. So what I'm doing here is I'm kind of just relieving some of the bind by using this 5/8, I think this is a 5/8 inch reamer. And I'm just basically going to use it as a hand reamer. Oh, I guess I must have cut that out. But anyway, it worked out. So this plate was moving a little too tight for a person to push and pull, but it's no problem for the molding machine. And you do kind of need it to be tight, because if your ejector pins have too much play in them, oh, it looks like I did actually use the reamer, then you can get plastic flash around your ejector pins. And in really bad situations, you'll actually squirt plastic back into the mechanism of the back of your ejector system of your mold, and then and your pins could jam up because they get like this this plastic sleeve molded around them, and that's just generally bad. So there you gotta develop a feel for tight versus leaky, and it should be hard or not possible for you to manually move the plate. But if you have too tight of a pen, then it could start galling up and freeze up in your mold, actually physically weld from the galling action, and then break off. And then you've got a pen that's forward in your mold, and your return pins won't fix that. So that's where the art of, I guess, mold making comes into play. But here I'm one at a time. I squeezed in these return springs, and these return springs actually result in the ejector plate being farther back than normal. So a very important thing is you don't want your precision reamed holes to be more shallow than the natural spring location of your return pins. You want your pins to be fully engaged in the leading plate of your core on the B side, even with fully relaxed pins. So there you can see there's about 3/8 of an inch of basically relaxed spring, and your ejector pins still need to stay in the precision reamed holes. So think about that when you actually ream the holes in your mold side or your eject side for your ejector pins. Because if your ejector pins goes past your precision reamed area into more of a clearance hole, it may actually get caught, and then when you basically do the final bolting or tightening of the back plate of your mold, you're actually pushing your ejector pins to their final location as you squeeze out that little gap that you see, so that you have pretension on your return springs themselves. And if the ejector pin gets hung up on a ledge between your clearance hole and your reamed hole, then you'll buckle that pin while you're tightening this plate down. So I'm constantly looking in there, and I'm looking for ejector pins that are starting to get S-shaped or buckled or starting to want to get broken. If I see one, then I got to basically unbolt the back plate and deal with the hang-up of any of the pins that are starting to bend during this operation. So you see I'm constantly looking in there, just seeing if all the pins are happy or not. Or basically, are they remaining straight, and are they pushing forward to their final depth on the core, the B side of this mold. And then there we're basically driving it home. You can see there's still a little bit of a gap. I guess I had some issue. Oh, I must have had to grind off more of the tips of the threads of these bolts. So anyway, it all worked out though, I promise. All right, so I'll retighten. And if your pins are a little bit off, then you can do tricks like you can put shims of paper in that little gap between the riser block and the bottom of your mold. Or you can add shims of paper underneath your ejector plate, so you can tailor and kind of dial in the depth of all of your ejector pins in your mold itself. And there you can see that we're good. I think my back plate was a little bit rough on the alignments, because all of these steel blocks were just flame cut that I bought off the shelf from a local metal manufacturer. So some of them I had to machine off more than the ideal outer dimensions, just to get rid of some of the flame cut nastiness. Because this is kind of a budget mold, so I basically just bought regular hot rolled steel that was flame cut and on the shelf at the local metal supply company. All right, so there you can see the pillar installed, and it's exactly the same height as the riser blocks. And those pillars that you see will prevent the mold face on the B side from collapsing or bending down when it sees the pressure from the injected plastic. So now's the moment of truth. I am going to align the A and the B side, and my alignment pins hopefully will guide into the corresponding bushings that are pressed in on the B side. And you got to lube this up, because this is also a highly precise fit. It's basically plus or minus 1/1000 of an inch or 25 microns. And there's 4 pins, so it's technically an over-constrained fit, so it's a little tricky. But yeah, you got to smack them in, and usually once the lead pins get halfway in, it finds its alignment and just kind of slaps in. Now this is a alignment ring on the A side of the mold, and this alignment ring keys into a round pocket on the molding machine itself. And here I'm just cutting the copper cooling lines to be reasonably short. And unfortunately, these cooling lines wound up being on the bottom side of the mold, which makes it a little tricky to load this mold into the molding machine, because you pretty much have to put some rigging blocks under your mold so that you don't crush the copper down, because that copper faces down in the mold itself. So it's a little tricky. I just got some blocks of wood to clear the copper lines. And as it turns out, with the pilot run, we didn't even actually hook up the cooling lines. All right, and here we are. This is the finished mold loaded in the molding machine. We got a little creative with the mounting, since my toe clamps slots didn't totally jive with the whole pattern on the dual shot molding machine. But it all worked out. We ran about 400 parts. And this is the B side, again with some creative mounting. And everything worked out. I did actually mold about 100 parts, and then looked at the surface finish, and then I went in and did some additional sanding, basically just hand mold finishing, and some Brillo work on this face. And yeah, but we are good to go on this project. I've got some footage, some cell phone footage of molding these parts. This is the part as it ejects out of the mold. Yeah, there was, on the B side, there was just a couple of tool marks that were still there, which I cleaned up. We didn't have to hook up the cooling because of the short run, and I also used this nice fan right here to basically keep the molds in spec for temperature. Yeah, a lot of times you don't always need to have a big fancy refrigerated chiller system to keep your molds in process. Sometimes just slowing down your mold slightly and then adding a fan to it will do the same trick. Not always, especially with steel molds, because steel molds conduct about 1/10 as good thermally as aluminum molds, which I usually do more aluminum molds. So we can, oh, and by the way, I loaded this mold when it was in the other unit, the other bay, and now it's in the expanded bay, which is unit R. And there was an episode where we moved this molding machine into this area, so everything is in general disarray right now. In fact, you can still see some of my mold finishing stuff. And we need to basically relay out or set up unit R, which has been just a warehouse for production. Here's some of the other parts that were molded, and then I cleaned up a bit. We also use these gauge pins to measure the diameter of the holes, the through holes in this part. Again, I can't talk about what this does until, or if, my customer gives permission. Maybe he wants to advertise these, I don't know. Anyway, but yes, unit R is still a complete mess right now from the move. And we are still going to move this molding machine basically into this area right here once we get a chance to set it up. I think this is the oh, here they are. This is the first parts that I molded. which need a little bit more cleanup on the B side or the eject side.
So it has been a very busy couple of weeks with moving this molding machine and also simultaneously trying to get this order molded and shipped, as well as the new large molding machine, which landed in the place that this molding machine used to be in. So thanks for watching Dragonfly Engineering, and I will be releasing more videos. I have a backlog of footage now that things are a little less chaotic here in the shop. All right, I'll see you guys next week. Thanks for watching.